It's great to be here. Topic of today, API authorization with an open policy agent. And I'm Anders. I work as a developer advocate at Styra, which is the founders of the OPA project and also the main maintainers. I have a pretty long background in software development. I used to work primarily in identity systems, so basically how to prove who you are in various digital systems. When you're in the identity space, you're often asked, like, how do we, like, now that we know who this user is, like, what do we do with that information? And when you're in the identity space, that's not your problem. Like, that's somebody else's. That's authorization. So for a few years, I used to answer that. It's like that's not what we do in our product. We just issue a token or some form of identity for the user. We don't really solve authorization. So a few years later, I ended up at a company where they wanted me to solve authorization. So then it became my problem. And that's how I got involved into the OPA project. So I've been working with OPA both as an end user and for the last few years at Styra. If you want to reach out, just my first name followed by my last name and all these various channels. So what's the problem we're trying to solve here? Well, the problem that we're going to look into today is basically this: how do we do authorization in distributed APIs? And the answer is it's kind of complicated. I think we got a few hints of that from the previous talk here. So before we kind of jump into authorization, since my background is in identity, I just want to give you a kind of glimpse into what that looks like. So if we start with the kind of monolith architecture, and I'm not going to bore you, I think you're all very familiar with that, but basically moving over to microservices, we have all the same components. It's just the way that they communicate with each other that's going to be different. Today we are mainly concerned with authentication and authorization. So if we were to look into like the monolith architecture and application, at least with regards to kind of identity and access control, it's a very simple model, right? You just have a user. That user presents some credentials to your application. Everything is handled inside of the application. So the user identity is verified. If the user exists and this has valid credentials, we'll go and check, is the user allowed to do this? And if they are, we're going to go and fetch them the data they wanted. So in a distributed application, authentication is commonly delegated elsewhere. But up until now, access control has pretty much remained the same. So if we were to move this kind of naive image of the monolith architecture and just say, like, let's just split up our monolith into 5 or 6 different microservices. That same model was going to look something like this. So we basically have a user presenting credentials. Credentials get passed around. They each need to verify identity. They each need to verify permissions before they actually get to the data. And I'm pretty sure you all can see a few issues with this model. So the first issue here is obviously this. There's really 2 issues here. The first one is, of course, that we're passing around credentials. We're passing around credentials in services that should have no idea about credentials. They should not be aware of that kind of information. The next problem is, of course, all these red arrows here. For each request that enters a service, we need to go over to the user database to see is this a valid user based on the credentials provided. So in the identity world, we can solve this by externalizing that responsibility to an identity system. And this is really the best kind of place you can be in, because when you can delegate, it means it's less work for you. You just say, that's not my problem. That's basically what we did with identity. We said our microservices are not concerned with the identity of our users. We just, when the user wants to access something here, we just send them away to this identity system where they provide their credentials. And in return, we issue a token. So there's no longer a need for each of these services to kind of reach out to the user database or even the identity system. So we effectively cut half of these arrows out. But everyone wants a token. And so if everyone wants a token, it's not just like us people. We have API integrations. We have mobile devices, IoT devices, and whatnot. So this is basically what OAuth does. It provides as a set of flows on how to ask people, which would be the interactive flows, or as machines, which is like the non-interactive flows, provides us a set of flows for how to obtain these tokens. But interestingly enough, OAuth, which is all about tokens, says nothing about what a token is. So it just says that's up to the implementation. Another interesting aspect of OAuth, it's labeled as an authorization framework. It's basically in the title. It doesn't do authorization. It provides a very coarse-grained way of doing authorization, which is this concept called scopes, which basically just says this token I just issued can be used in this or that application. But that kind of leaves it at that. So it doesn't really do authorization, which is interesting for an authorization framework. So another thing OAuth doesn't say anything about is who is this guy or girl. So that's basically what OpenID does, or OpenID Connect. It adds an identity layer on top of OAuth. It just says, like, the way you got your tokens, that's fine. Carry on doing that. I'm also going to add an ID token here that describes who this user is. All right, so if OAuth does not tell us what a token is, how do we know? Like, what do we invent this ourselves? We could, of course, use APOC tokens. That's secure. If we have a token which is like ABC 1, 2, 3, it doesn't mean anything. So in order to know what does this token mean, who's behind this token, who was this issued for, all these services, they need to go back to ask the identity system that issued a token. So if you can see, we're kind of back to the same problem we started. Rather than going and asking the database, we now ask the identity system. What does this token mean? So that's not a very good model. So what we did here in the identity sphere is basically this. We kind of started looking into self-contained tokens, where you sign a token and you not just associate some data with it, but you actually push that data inside of the token. So what you can do now is just basically you just open up that token, decode it, and you can read that this is the user, this is the roles, and any other data that you might find useful. And of course, JOTs, they're everywhere, so there's libraries available for any language or platforms, and so on. One thing to be aware of, though, is be aware to not kind of issue JSON Web Tokens outside of the realms of your own system, because if you issue a JOT directly to a user, it means that they too can just open it up and read whatever contents you might have on them. And that could be fine. It's an information leakage, but it's also things like just the formatting of your attributes. You might call it user, you might call it username, you might call it email, you might call it email address. Things like that tend to be hidden dependencies. So once the user sees, oh, there's some cool data here, I could use this for my mobile app. 2 years later, you want to make an update in the structure of your JSON Web Tokens, and you just brought 2 million mobile apps. You just broke them, and you had no idea because that was a dependency you did not consider. But anyway, we have a fairly good, with all these, with OAuth2, with OpenID Connect, with JSON Web Tokens, we have a fairly good model for distributed identity. So that problem is basically solved. All right, so now let's do access control. So if we go back to the name model, we see authorization logic is embedded in our applications. They're all querying the database for permissions. Still, this isn't a very good model. The more microservices we add, the more load we're going to add to this poor permission database. And chances are pretty good in any larger organization that permission database is going to be like a mainframe or something that does not scale at all and does not like that kind of load. So where do we do it? One model which was presented just here before my talk is the gateway model. It is a very common model. It's a simple one. It basically says when a request enters the perimeters of our system, we do an authorization check. So we check, should the user be allowed? There's a single lookup being done, and once you're past the gateway, it's an open highway. You can do whatever you want, because obviously you must have passed the gateway in order to reach here. One problem with this model is, of course, it's not very secure, because again, once you are past the gateway, and if you manage to get past the gateway, there's basically no security measures in place, because all these services assumed that you must have passed the gateway. Another issue is, of course, if service number 4 here wants to run a cron job that queries service number 5, it's not going to pass the gateway. So how do we know that operation is permitted? But it's fast. It doesn't provide much in terms of security. So if we go back to this kind of naive model that we started with, this is actually a fairly secure model. It's really what we, like, I don't know, 25 years later would come to call the zero trust security model. It's basically the naive model where we do all these lookups. It's slow. It still has a single point of failure, but it's fairly secure because we do these authorization checks everywhere. So great. Like, the good model is obviously also the bad model. So how can we make this all better? The first thing, I don't know if it's apparent here, but we just flip the direction of these arrows. So rather than having all of these services query the database, we just say the database or some service connected to this database will distribute the data to our applications. So there's a dependency, but it's not an online dependency. It's not a direct dependency. If the database goes down for a few minutes, the data is already distributed to our applications. So another problem here, we talk about it, is that authorization logic is embedded in our applications. So a problem with this, in any large organizations, you're going to find microservices written in all these different languages. It's basically one of the promises of microservices, that one team can write their services in Clojure, and another one can do it in Go. And these teams can still work together by just exposing REST APIs and API contracts. Another issue with this, but an issue with this when it comes to things like authorization is, of course, like, how do we audit this? If we have authorization code which is like scattered over 8 different programming languages, they all have their own way of logging, they all have their own way of doing things. You're basically going to have 8 different authorization implementations. So enter Open Policy Agent. So OPA is an open source general purpose policy engine. It offers a unified toolset and a framework to work with policy across the stack. When we talk about policy, policy is basically the same thing as a real world policy. It's a set of rules. So it's basically a set of rules or a way to define rules across our systems. One idea with OPA kind of borrowed from the identity world is this idea of decoupling and delegation. So again, a problem which you can delegate to somebody else, that's a good problem. So we kind of want to keep that model. So our applications, ideally, they have no idea what a user is, a role is, if a user is permitted or not. We decouple that, delegated that responsibility to OPA. Policies are written in a declarative language called Rego. It's a general purpose policy language, so you'll see OPA in a wide variety of contexts, like Kubernetes admission control, Terraform, CI/CD things, basically anywhere where your organization wants rules, you can find OPA. So to summarize it down, the Open Policy Agent project is super dope. I finally have a framework to help me translate written security policies into executable code for every layer of the stack. That kind of sums it up. How does it work then? A simple model, we have a request coming into our service. And when we say service here, we have a very broad definition of service. It's basically anything that services a request. So it could be a microservice, it could be a Kafka broker, it could be a database or a Linux PAM module, anything servicing a request. Rather than having that service determine should this operation be allowed or not, we delegate that question to OPA. So we send a policy query. Policy query is JSON. Could include the username. It could include the resource manifest if it's Kubernetes or whatnot. Any data that is relevant to that query. OPA, based on the policy we kind of loaded in beforehand, makes a decision. It says either, yes, this user should be allowed, this user should not be allowed, or this resource could be deployed or it should not. And sends that back to the service. And the service then enforces that decision. So that's basically the policy decision model. So the deployment model, on the other hand, OPA, it's a self-contained, lightweight little server binary. I think it weighs in on like 50 megabytes or so, so fairly lightweight. And the deployment model in our modern kind of distributed systems is not that you have one big OPA somewhere that all your services go and query. Then if that was the case, we kind of reinvented all the problems we had with how we used to do authorization. So it's a lightweight process. You distribute it everywhere. If it's Kubernetes, it might be a sidecar, it could be a daemon set or whatnot. But OPA should run in as many places as possible. You don't want that bottleneck. And applications commonly communicate with OPA over its REST API, but there are more esoteric alternatives available as well. And as for policies, they're written in a declarative high-level language called Rego. A policy consists of any number of rules, just like a real-world policy. And I think we saw it before at any request and response is any valid JSON object. So you can return Boolean values, you can return strings, objects, and whatnot. And another benefit of treating policy as code is, of course, that makes your policies testable. So you can run a test suite on your policies to verify that the baseline security we're aiming for here is achieved. It's a well-documented project. There's a playground available, so you try it out. Okay, so with that in mind, we kind of we deploy OPA everywhere. So OPA running next to our service, the policy decision model has all these services. Rather than having to make these decisions themselves, they query OPA. And in a real-world scenario, of course, we probably wouldn't have a permission database pushing data. It's not really the job of a database. But we'd rather have something like a control plane. And this could be an Nginx server. It could be an S3 bucket. Or it could be something like the Styra DAS, which is a commercial control plane. So with this model, I'd say distributed authorization is solved. Questions?
We have time for a few questions. Who use open policy agents? Some people say yes, kind of. We try. Yeah, some people there. May I have yep, okay, there you go.
So I wonder, how does this compare to OpenFGA?
To OpenAPI?
OpenFGA, fine-grained access.
Right. So I've not worked too much with that. I think that is you can only aim for an authorization framework, while OPA is, again, it's a general purpose policy engine. So all these kind of other things that you can do, like infrastructure policies, Kubernetes admission control, CI/CD pipelines, and so on. So there's a whole bunch of kind of single purpose policy engines that are either kind of catering to the authorization use case, or they're catering to the infrastructure use case, or something else entirely. So I think like one of the key concepts or a key kind of selling points, if you can say that about an open source project, is that you have one way to define and describe policy across your whole organization. So, but on like a microscopic level, I have not done that comparison to OpenFGA, but I'm aware of the project.
Yeah, we have one question here.
With the OPA, can you also do things like attribute-based access control?
Oh, for sure. Yeah. originally there was like a demo included here with some Rego offering, but I couldn't find it kind of the time to squeeze that in. But sure, so OPA, it's in order to accommodate like all these different use cases. There's really no such thing as like you can only do RBAC or ABAC or whatever you want to call it, but you're it's a very open model, and you can do any of these kind of authorization models as you wish.
Another question around. Yeah, I have a question on my side. You know, about all this recent regulation, you know, like GDPR, privacy regulation, you know, privacy as code and stuff like that. How today, do you see any use case where actually, you know, maybe in a CI/CD pipeline using Open Policy Agent, we're able to check kind of policies like privacy policy or others? Like, how would you check privacy policies, you know, in a CI/CD pipeline using OPA?
Right. So as long as kind of the privacy either policy or the data is described as either JSON or YAML, or so OPA basically works on any kind of structured data. So and it doesn't really care what that data is. That's up to you to determine the value of that or the usefulness of that. So as long as the data is in or can be made into JSON or YAML, you can write policy on that.
So if I write my policy into JSON or YAML, then I can kind of match with Open Policy Agent and stuff?
Yeah, exactly. Or that's the format of your data. That could also be. So there's a whole bunch of like more esoteric or fun use cases. There's been people writing like RPG game engines in OPA and whatnot. So there's basically anything where you have rules, that's a good use case for OPA.
Yeah. I see some people saying yes.